Number 2 here looks for us to find the value of y. We're going to express this in the simplest radical form. Notice this is Pythagorean theorem, so we can now just set up regular Pythagorean theorem. A is equal to 10, B can be equal to 5, and C can be equal to y. So it is 10 squared plus 5 squared is equal to y squared. 10 squared is 100 plus 25 is equal to y squared. 125 is equal to y squared. To solve for the y, we can square root both sides. So it's square root of 125 is equal to y. The square root of 125 can be broken down into radical 25 times, I think, 5. This splits down to radical 25 times radical 5. The reason why we should do that is because radical 25 becomes 5 and the radical 5 stays the same. So the radical 25 becomes the 5, then the radical 5 becomes just 5. Okay, there you go. That's how you use Pythagorean theorem and you simplify it. B. A equals to 6, B equals to y, C equals to 85. So it becomes 6 squared plus y squared is equal to square root 85 squared. Notice 6 squared becomes 36 plus y squared. The square and the square root here will cancel, right? And then as a result, we can see that it just becomes an 85 here. Subtract 36 to both sides. Subtract 36 to both sides. We get y squared is equal to 85 minus 36 is 49. If you take the square root of both sides, square root of y squared, the square root of 49, you will get here y is equal to 7. Okay, it's technically plus and minus 7, but the value of the length can only be positive. So the value here is just 7. C. A equals to 9, B equals to square root 19, C equals to y. So 9 squared plus radical 19 squared is equal to y squared. 9 squared becomes 81. The squared and the square root cancels. That is just a 19 is equal to y squared. 81 plus 19, it is 100. That equals to y squared. If we square root both sides, we get square root of 100, which is just 10, is equal to y. So there you go. That is how you solve for the side using Pythagorean theorem, as well as simplifying the radical.